Hmm. So analysis. So what do you mean by analysis? This is very, very important one in the algorithms. Be careful with this. Okay, be careful with this. This is very, very important one. So why this analysis is important? I will want to tell you. Suppose consider here. Suppose consider two friends are there. Okay, two friends. Two friends are there. These people, what they will going to do? They will going to identify one problem. Think like that. There is a problem. One problem is there. Okay, so there is a one problem. So this is the problem. Okay, for this problem, these two friends, what they will going to do? They will going to write an algorithm. Okay, consider like this. This is a big problem. Okay, so this is a big problem. So what these people will do, two friends, they will going to write an algorithm that is called it as A1 here. Again, so one more friend they will going to write that is A2. These are the two algorithms they will going to write. So A1, what happens here? So when you execute this algorithm, please understand, when you are executing this algorithm, it will take some time. That is, the time is equal to n square. Okay. Again, this algorithm, A2 algorithm, it will going to take some time. That time is equal to n cube. Now, we have to understand when you are executing any algorithm, we know very clearly it should take very less time. Okay, it should take very less time. Okay, not more time. When you consider this one n square and n cube, which is more here in terms of time, so the n square is very less compared to n cube. So that is the reason why what they will want to say. So n square algorithm is better compared to A2. So this is what. Okay. So this n square, it will going to execute in less time. Okay, it will going to execute in less time compared to n3. So that is the reason why experts always consider time compared to space. Okay, so that is the reason why this algorithm, A1 algorithm, taking very less time to execute. It is taking n square, and A2 algorithm, it is taking n cube. So that is the reason why we are going to take this algorithm. Okay, suppose think like that. Same friends. Okay, same friends. Example. Okay, same friends. What they will going to do? So they will going to write one more algorithm A1. Again, one more algorithm A2 for a same problem, for this problem only. Okay, both algorithms here, both the algorithms will going to execute n square. Okay, it will going to execute n square. Understanding everyone? Both the algorithms, it will going to execute n square. Now you tell me which one I have to select. Which one I have to select in this? Okay, both are taking same time. This one also taking same time. This one also taking same time. It means that both the algorithms are good in that you can take anyone. Understanding everyone? You can take anyone in this. So that is what exactly I'm talking about. So when you're writing a algorithm for one problem, if we have to consider the time complexity, not space complexity. So that's very, very important. Okay. Again, consider one more. Again, you consider this one. So like this, there is a problem. Problem. Okay, there is a problem again. So this problem we're going to have a two algorithms. Okay. So one is A1, another one is A2. Whatever you want it, you take it, no problem. This A1 will going to take n square. Again, A2 will going to take n cube or n. So which one you will going to select? In this algorithm, this is example 2. You take it example 2. This is example 1. Okay. So in this example, which one you will going to select? Basically, you will going to select this algorithm because it is giving less time. Okay. So if you go to example 2, in this you will going to select any one. Okay, not both. Any one algorithm you can able to apply. Nothing but what? Here choose anyone. Okay, anyone. Okay. Now, in this algorithms here, there is a problem. Two algorithms are there, but in this algorithm, what we have to see? We have to see the always time only. Okay, always we have to see the time. So that is the reason why here it is giving n square, here it is giving n. which one you will going to select? Basically, you will going to select which one will going to give the less time to execute the program. Okay, so that is the reason why time is more important than space. Understanding everyone? Time is time is more important than space. Be careful. All this example. I'm unable to, I didn't got the time to explain these two, so that's fine. Okay. Okay, Jitu, fine.
Yes, sir.
Okay. Now, so I think everybody understood. Suppose think like that. Okay, suppose think like that. Uh, so whatever the problems we discussed right now, one example 1, 2, 3. In that, if you are failed to choose the algorithm, okay, if you are failed to choose the algorithm, again go back and select it in the design which algorithm you want it. So that is also possible. You can able to do in that way. Again, if think like that, there is a problem like this. I will make it small. Okay, think like there is a problem. Okay, there is a problem. Consider for this algorithm, please understand, for this algorithm, consider you will going to have a algorithm A1. Again, you will going to have a algorithm A2. Again, one more algorithm, you will going to get it A3. Okay, nothing but what? For one problem, okay, for one problem, so many algorithms are there. Okay, this is also one algorithm, this is also one algorithm, this is also one algorithm. So many algorithm is there. Hence, you don't know what to choose. You don't know what to choose. That time, what we have to do? You tell me. That time, what we have to do? So that time, you have to understand which is the best one. Please identify which is the best one. If A2 is the best one, then choose this one. If A3 is the best one, choose that one. If A1 is the best one for this particular problem, choose that one. This is how you have to identify. So this is one important thing. Again, so what best way we're going to select? So choose the best one. Okay, choose the best one. Okay, sir, we understood. Choose the best one. But how will go get to know which is the best? So in this best, so what are the basically there are two factors. You have to follow the in the best way. There are two factors. Okay, there are two factors. These two factors you have to follow. One is time complexity. Okay, one is time complexity. Another one is space complexity. So these are the two important things we have to get to know. So what is this time complexity? Time complexity is nothing but CPU time basically. Okay, time complexity is nothing but what? It is a CPU time. How much amount of time it will going to take to execute that particular algorithm. Again, space complexity is nothing but it's a main memory. Main memory. These things I discussed. Okay, so these things are important things we discussed. Those things left out, that's what I am talking about. So I think you people are got it now. If you are confused what to do and which one is best one, you have to select the time. What are the factors you have to focus? These two factors. One is time complexity, another one is space complexity. These are the best factors. You have to choose it and you have to select it. So that's what I am talking about. If the algorithm, this is the thing like that, there is a problem, you will going to have an algorithm A1, A2, A3 algorithms are there, three algorithms are there. So in that, so you have to understand very clearly which one is the best one you have to select. If the best one, nothing but best is nothing but what? Which one gives you less time to execute? That is the one best one. In that also we have to identify time complexity as well as space complexity. These are the two factors you have to focus. Clear? Clear guys? Okay, just message. Okay, we will see the next one. Now, I'm talking about time complexity. That is all about analysis. That is the reason why we will use it to do the analysis. Why? Because always we have to choose the best one. Okay. So when you go to the algorithms, always we have to choose the best. So that is the reason why analysis is required. Okay. If you are confused, suppose confused to identify the algorithm, confused to identify the algorithm framework, again confused to select the right algorithm, then so we need a analysis. Okay, so I think you have choose the wrong one. Think like that, there is a problem like this problem. think like that, you have choose the wrong algorithm, that is A2, like that. So then what we have to do? We have to do with the analysis. What is the time complexity as well as space complexity? Both the things you do it, then you will understand, okay, whatever the algorithm I have chosen, that is not the right one. That is the reason why you go back and select in the algorithm design part. Okay, again, you choose the right algorithm. Then you will go into do the analysis, time complexity as well as space complexity. You will get to know, okay, whatever the algorithm I have selected, that is the best one now. So hence before what I selected, that is not a good one. So that is the reason why analysis required. Okay, so this is what. Clear? I think everybody clear. Fine. So this is the reason why analysis is required. Now let's talk about time complexity. We will going to discuss about time complexity here. Okay, everybody's here. So we are talking about time complexity. Time complexity. Okay. So what do you mean by time complexity? Suppose there is a program P. Consider there is a program P. This program will going to take certain amount of time. Okay, nothing but nanoseconds, like that. It will going to take certain amount of time to execute the. Where it will going to execute, we don't know. Where it will going to execute. Okay, in the computer it will going to execute. There, how you will going to identify the time complexity of those things? We understood very clearly. So there will be two factors. Yes, there will be two factors. What is that? One is time complexity, another one is space complexity. We understood. But what is this exactly time complexity? Time complexity is nothing but, okay, see here everyone, this is the formula. Morning I told you, time complexity. Time complexity is the time complexity for any program. For any program. So that is equal to, what is that? Compile time. Okay, compile time plus nothing but for a program. Okay, plus runtime. So for a program. Okay, so this is the formula, you have to keep it in your mind. So that is what in the short form what we're going to do, we will going to write in this way. So what is that exactly? So time complexity of a program, so that is equal to, okay, compile time, okay, for a program plus run time for a program. Okay, so this is very important. Okay, now I think everybody understood how to find the time complexity. So you will going to write a program. Think like that. This is a program you will going to write. So this program given to compiler. This is, you can able to see the compiler. There will be a compiler. This program will be given to compiler. So basically we know that. What do you mean by compiler? Compiler is nothing but a software. Okay, it is a software. Yes or not? Compiler is nothing but what? It is just a software. Okay, compiler. So compiler is what here? It's a software. Again, so what will, how we will going to identify the compile time? When you give the program to compiler, it will going to compile each and every line. Okay, it will going to compile each and every line. What is that basically? That is called it as compiler. This compiler compiles each and every time. So that time we will call it as compile time. Understanding everyone? That time we will call it as compile time. So every line it will going to scan and it will going to check any errors are there. Errors are, any problem is there, like that it will going to check. So that time we will call it as compile time. This is important. Okay, how we will going to identify the compile time? Basically using compiler. Okay, based on compiler. Based on compiler. Who will going to give the compile time? Please understand, I need a compile time. Please execute a program. Suppose main function, think like that, main function is there. Okay, open again here, printf. Okay, hi, this is what, this is I wanted to execute. Okay, so what we need a time, compile time for this particular program, this particular snippet code. Okay, what will go, where we will going to give this code? This code will be given to the compiler. Okay, so compile, how you will going to get the compile time? Based on compiler, which compiler you will going to use. Okay, So there are so many compilers are in the industry. Okay, so many compilers. Currently, we're going to have GCC, VCC. So many compilers are there. So based on that particular compiler, you will going to get the compile time. Don't say that every compiler will going to give you same time. Okay, each and every compiler will going to give you a different time. Okay, suppose think like from Microsoft compiler, it will going to give you different time. From Linux compiler, it will going to give you different time, like that. Overall created the compilers based on that compiler, so it will going to give you the compile time. That one thing you have to understand. How you will going to get the compile time? Based on the compiler, which one you will going to use. Suppose example, in labs and all, we will going to use GCC compiler, okay, C compiler, okay. So those things you have to. So based on those compilers, you will going to get this compile time. That is one thing, okay. Again, runtime, I will going to get it, okay. I will going to get the runtime, okay. This is please, yeah, understand it. Runtime will going to get it based on processor, okay, based on processor, okay. So this is very important. So basically processor is what? It is a hardware. It's a hardware. Clear? Everybody clear everyone? How you will going to get the runtime? Please understand. How you will going to get the runtime? Based on, okay, how you will going to get the runtime? Based on processor. It's a hardware. How you will going to get the compile time? Based on compiler. So then only you will going to get the compile time. So what is this compiler? It's just a software. Compiler is a software. So if you combine these two, compile time plus runtime, then you will going to get the time complexity. That is what exactly I am talking about. TC. Clear? Clear now, everyone? Everyone clear? Okay. Understood. We talked about all. Okay. We talked about all this. What do you mean by time complexity? How you will going to get the time complexity? That is what exactly I'm talking about here. Okay. Please understand. These lines are very important. How you will going to get the time complexity? Time complexity. How you will going to get the time complexity? Basically, time complexity is combination of, please understand, time complexity. Okay, time complexity is equal to combination of compile time. Okay, compile time plus runtime. Okay, when you do these two, then only you're going to get the time complexity. So that is what I wanted to say. That's why so many people don't know. Okay, what do you mean by time complexity? Is nothing but, so they will say it's a time complexity, but how you are getting time complexity? Because of compile time and as well as runtime. So there will be a one software compiler, again there will be a one hardware, that is preprocessor. So you will going to run the program in the hardware, again you will going to compile in the compiler. So both the things, when you combine both the things, you will going to get the complexity. That is what we call it as time complexity of a program. Okay. Now please understand here. C compiler. Basically, you will going to find C compilers. Okay, C compilers. C compiler is means. Okay, C compiler means. Please, everybody, this is very important. These are topics are very important. C compiler means it's a C language rules. C language rules. Nothing but what? Suppose you will going to write a program like main. Okay, main. Okay, printf hi. Okay, like this you will going to write a program. So this program will be given to this particular compiler. Okay, the program will be given to this compiler. What it will going to do? It will going to check each and every line. Nothing but syntax. It will going to check syntax. Okay, syntax. It will going to check. So that is the reason why compiler is nothing but it's a C language rules. C compilers are nothing but C language rules. Suppose Java compiler, you have a Java, right? So suppose Java compiler. Okay, suppose Java compiler, nothing but what? Java language rules. Okay, Java language rules. Okay, I think everybody understood. So nothing but what? Every language will going to have a compiler. Okay, C will going to have its own compiler. C++ will going to have its own compiler. Again, Java have its own compiler. Okay. Again, Python it will going to have its own compiler. So like that. Okay. So whatever the language you will going to learn, that language will be compiled in that particular compiler. That is the reason why I said this line. What is that? It's a language rules. Okay, it's a language rules. Clear? I think you people are clear here. Okay. Now, here, so what is this compiler is nothing but I told you it's a language rules. Again, what is the language rules is nothing but here there will be a set of rules. Okay, so for example, we know that here you can able to see first we have to write the main function. After that you have to open the body. After that you have to close the body. Nothing but what it says that exactly it is a set of rules. Set of rules. Okay, suppose example think like that. I wanted to write a data type int. Okay, a is equal to 10. So this is the syntax, nothing but set of rules. This is, so first you have to write the data type, after that you have to write the variable, after that you have to write the value. So if you do like this, okay, then it will going to accept. If you are not writing, suppose think like that, if you write like this a, okay, int, okay, that is equal to like this. If you write like this, what it will do? So it will not going to accept. It will not going to accept because it is a set of rows. Okay, this compiler what it will going to do? It will going to have a set of rows. If the rules are not satisfying, definitely it will not going to accept the language. Okay, definitely it will not going to accept the language. Okay, again one more thing. This compilers, okay, here compilers. Compilers can be written. Please understand these things. Compilers can be written, can be written in any language. Compilers can be written in any language. Suppose take this one, C. No need to write C. Okay, here I will write. Okay, here I will write. So suppose example, you take the language C. C can be written in Java language. Okay, so C required a compiler. Yes or not? C required a compiler. This compiler can be written using Java language. Okay, again, Java compiler can be written in C. Python compiler can be written in Java. Okay, Python compiler can be written in Java. Like that, there is no rules, set of rules saying that you have to be compiler. Suppose example, C compiler should be written in C language, like that. There is no such kind of rules here. You can able to write a compiler in any language. Okay, that is one thing we have to observe here. So when you are using the compilers, no need to worry about which language they have written all those things, whether it will going to compile, whether it will going to satisfy the rules or not. Only we have to take care of this. Clear? I think you people are clear. So let's see further. Okay, for that one, if you are still thinking about, sir, C language, okay, C language, can we write the C language compiler in assembly? Okay, assembly language. Yes, of course, yes. For this, yes. Why? Because initial days, basically initial days, when we are using C and all, initial days, so basically C language is written in assembly language. That is what we call it as the AX, BX, CX, move, all this instruction. This is what we call it as, what is that? Assembly language. Okay, so like using like this language, assembly language, they have written the C compiler. So that is what exactly I'm talking about here. When you are using any compiler, that compiler can be written in any language. There is no such rules. You have to write Java in Java compiler, Java language only. Okay, Java compiler should be in the Java, like that. There is no such rules. Okay, so that is one thing you have to understand. It means that what is that? X. Suppose think like that, X compiler is there. It can be X compiler. Okay, some X compiler, whatever it may be. It can be written in any language. It can be written in C++ or Java, anything, whatever it may be. That is what exactly I'm talking about. So compilers are very, very important. Why I'm talking about compiler? Because we have to identify the time complexity. So time complexity is equal to nothing but what? So compile time plus runtime. So that is the reason why I'm talking about compiler. Okay. So that's why X compiler, everybody observe here, X compiler, I don't know, or whatever the compiler you take it, X compiler, okay, written in, written in, written in X language. Yes or not? So that is it, it is left to you people. Whatever the language you take, you written in that particular, write the compiler, what is there in that? So these are the very, very important things. Be careful with this. Why? Because I'm talking about these things because these are all ignored. Okay, because some areas we cannot able to discuss all those things. That's why I use it to take classes evening. These things we cannot able to discuss there. So that's why. So compiler is nothing but here when you are finding the time complexity, both the things will going to play important role. Okay, compile time as well as runtime. So then only I will going to get the time complexity. Otherwise, I will not going to get any kind of time complexity for any kind of program. So that is what. Okay. Again, here, one thing you have to understand here, nowadays what they are doing. So they are doing like this. Okay, suppose you wanted to write any compiler. Nowadays, suppose example, C language, C compiler written in C language, like that they are doing currently. But no need to worry about all these things. You can write whatever you wanted. But one thing is clear. Okay, please observe here. One thing is clear. The faster. Okay, faster one. Suppose think like that, C language is faster in execution. Then use the C language to write a Java compiler. Okay, that is better, no problem. So that is the reason why I'm talking about all these things compiler. Why? Because the reason is when you're writing a compiler, when you're writing the compiler, you have to worry about the fastness. Okay, fast, how fast it will going to execute. Okay, so if the compiler, if suppose think like that, you are executing a Java program. Okay, think like that, the compiler is written in some X language. Okay, so that is slower. If another language is giving faster, means you can go for that one, no problem in that. Okay, again, one more thing you can able to see in olden days and all, if you want to execute a program, directly they will going to use the assembly language. Okay, directly they will going to use the assembly language. Assembly language. Because why? Because the reason is this assembly language will going to directly communicate with the hardware. Okay, directly it will going to communicate with the hardware. That is the reason why it is somewhat faster compared to all this compiler. Assembly language is so fast because directly it will going to communicate with the hardware processor. Okay, no compilation, nothing is required. Basically, when if you go to olden days and all, they will going to use the commands. Okay, commands, using commands, because directly it will going to interact with the kernel. Maybe you can able to learn in operating system kernel. I don't know whether you learned or not. So you can able to use the kernel. Okay, directly these commands will going to operate on kernel. That is the reason why you get the things so fast compared to compiler when you use the compiler. So that is the reason why in olden days they used to they normally use the assembly language, so that it will going to communicate with the kernel directly, and you are getting very faster rate in execution. Okay, so finally what I wanted to conclude here, please observe here, finally what I wanted to conclude here, compile time is based on compiler. That is what exactly I wanted to type. Compiler. Okay, time compile time is based on okay, type of compiler. Okay, type of compiler. which compiler you are using. So that is what. Again, one more important thing, execution. Here, execution, execution, execution based on type of processor, type of processor. See, that is what I am telling you. When you are buying a computer, so many people ask me, so what type of computer we have to buy? So this is a software, you can able to get the softwares, but this hardware part, processor part, basically if you have a i9 processor, okay, it executes faster. If you have i5 processor, it executes faster. Suppose if you go to the dual core, okay, dual core 2, so it executes slower. So that is the reason why I am talking about, when it comes to the time complexity, you have to take care about one thing is compiler as well as runtime, that is called as processor. Okay, so compile time is based on what is that type of the compiler, what type of a compiler you, if you are using a bad compiler, think like that. If you are using a bad compiler, nothing but slower compiler, then execution it will going to take a lot of time. Suppose think like that, you will going to use a compiler, that compiler is a very good faster execution it will going to do, but the hardware, whatever the hardware you are using, suppose think like that, your processor is dual core, okay, dual core, core to duo. So then, so your compilation is fast but execution is slow, then it will going to affect on time complexity. This one you people are getting or not, guys? This one you people are getting or not? Okay, so that is, these things are important, that's why I'm talking about differently, separately these things. And these two are very different. See, if you have a good compiler, still if you have a good compiler, if you have a bad processor, still you are not going to get the good time complexity. That is the reason why, if your compiler also good and if your processor also good, means definitely you will going to get the good time complexity, nothing but very less time complexity. That's the reason why compiler is also important here, processor also important, hardware as well as software. So both are important, then only we will going to get the very nice less time compilation time for any program, we will going to get it. This is one thing you have to observe when you are running a program. Okay, clear?